Today I bought a Nintendo Switch for only 20 euros. At that price, even a broken unit is a steal. The seller told me that while his kid was playing, the console suddenly stopped working and never turned back on. The screen looks to be in perfect condition. There are a few scratches on the back plate, but that's not really important. It also appears to be the newer version of the Switch. The Joy-Cons are scratch-free, and most of the accessories are included. Let's plug it in and see if we can power it on. Let's try holding the power button for a few seconds and see if anything happens. Yeah, it looks like the seller was right. No signs of life at all. Let's check the game card slot and the micro SD slot. The game card slot is empty. The micro SD card slot is also completely empty. Let's try powering it on one more time just to be sure. Still nothing. All right, looks like we're going to have to open it up and see what's going on inside. Let's remove the last few screws. I was worried about water damage, but the device actually looks very clean, with no signs of liquid damage. Visually, I don't see anything wrong so far. I set my multimeter to continuity mode to test the capacitors. Using the schematic, I'm checking all the capacitors around the M92 and BQ charging chips to see if there's a short circuit. If we find one, it could indicate either a failed chip or a shorted capacitor. Both are usually easy to fix, as long as there is no damage to the CPU. I found a short on a capacitor near the BQ power chip. I'm going to remove it and check again to see if the short is still there. If it remains, that would indicate a shorted BQ chip. At this point, I'm pretty sure the chip is the problem. The capacitor is now removed from the circuit. My cheap multimeter can't measure capacitance values, but we can still check whether it's shorted or not. And surprisingly, it turns out this tiny 5-cent capacitor was actually the problem, and most likely the reason the console wouldn't power on. From the schematic, we can see that this is a 10 microfarad capacitor. I ordered a pack of replacements from AliExpress, but I chose a higher voltage rating, since manufacturers often use cheaper parts that fail over time. Again, my multimeter can't measure the exact value, but we can at least confirm that the new capacitor is not shorted. I first tried soldering the capacitor without removing the motherboard, but that didn't work. So let's take the board out properly. Before doing that, I need to protect this plastic connector with Kapton tape. Kapton tape can handle high temperatures, but to be safe, I'm using multiple layers. I'm heating the board with a heat gun at 420 degrees Celsius and about 50% airflow. I successfully soldered the new capacitor. Let's measure again to make sure it isn't touching the capacitor next to it. After checking the schematic, I confirmed that both sides I thought were touching are actually ground, so it's not a problem even if they make contact. Now we need to clean the leftover flux. I'm using a toothbrush and 99% isopropyl alcohol for that. Let's put the board back together and reconnect the connectors. I've connected all the necessary cables, and I'm going to test it before fully closing the console, so we don't have to open it again if something is wrong. Let's see if we succeeded. Yes, we got the Nintendo logo and the device is booting. We got really lucky with this simple fix. Now let's close everything up completely and test that everything works. Let's connect the Joy-Cons. I also have a micro SD card and a game to make sure everything is working properly. Earlier I didn't hear the fan spinning, so I'm still a bit worried about that. All right, everything works perfectly. The fan is spinning and the console is fully working again.